Picture this: 500 men scattered across 10 miles of wilderness. No phones, no radios, no instant communication of any kind. They're felling trees that weigh 40 tons, running steam engines that could crush a man in seconds, hauling logs down mountainsides on cables stretched 1,000 feet. One mistake, one miscommunication, and someone dies. A tree falls the wrong direction. A cable snaps. A locomotive derails. These operations ran with a precision that would make modern managers jealous. Crews coordinated across mountains and through dense forests. They synchronized timing down to the minute. They set production records that stood for decades. They built a communication system so effective, so brilliantly simple, that when radios finally arrived in the 1930s, many old-time bosses refused to use them. They didn't need technology. They had something better. This is the story of how American logging operations coordinated hundreds of men across impossible terrain without a single electronic device. Before we continue, subscribe for real stories about extreme jobs and forgotten industrial systems that actually worked. To understand why this was so difficult, you need to grasp the sheer scale of a logging operation in the 1890s through 1920s. A single camp might work a tract of timber spanning 10 to 15 square miles. We're talking about mountains, ravines, ridges where you couldn't see more than 100 yards in any direction because of the trees. The Weyerhaeuser Company's Camp 7 in Washington State employed 523 men at its peak in 1917. Those men were spread across 3 different valleys. The walking distance from the bunkhouse to the furthest work site was 14 miles, through terrain that would exhaust a modern hiker. These weren't small operations. A major camp would have a main headquarters with bunkhouses, cookhouse, blacksmith shop, and office. But the actual work happened miles away. Felling crews, skidding crews, loading crews, railway crews, all working different parts of the operation, all needing to stay synchronized. The problem was simple. If the felling crew dropped 50 trees in the wrong location, the skidding crew would spend days repositioning them. If the railway crew showed up before the loading crew finished, you had expensive equipment sitting idle. If the splash dam released water before the logs were in the flume, you wasted the entire reservoir. Time was money, but coordination was also life and death. A typical Pacific Northwest fir tree stood 200 feet tall and weighed up to 40 tons. When that tree fell, anything within 300 feet was in the kill zone. Crews needed to know exactly where other crews were working, exactly when to yell timber, exactly where the escape routes ran. But here's what nobody tells you about that era. These men came from everywhere. Swedes, Finns, French Canadians, Greeks, Italians, Americans from every state. In some camps, 14 different languages were spoken. How do you coordinate 500 men who barely speak the same language across 10 miles of wilderness? The answer involved whistle codes, runner systems, and a hierarchy so precisely designed that the US military studied it. The foundation of everything was the whistle system. Not one whistle. Dozens of them all across the operation, creating an acoustic network that could send messages over miles. The main steam donkey engine, the massive machine that powered the cable systems for moving logs, had the loudest whistle. On a clear day, it could be heard 7 miles away. But that was just the anchor. Smaller whistles were positioned at strategic points. The loading dock, the main railway spur, the splash dam control station. Each section of track had its own signal point. These weren't random toots. The codes were standardized, taught to every new man within his first week. One blast meant stop everything. Full halt, something was wrong, or dangerous. 2 short blasts meant start operation, resume work. 3 blasts meant quitting time, end of shift. But the codes went deeper than that. 1 long, 2 short, meant the high lead was moving. The cable system was about to haul logs. Everyone needed to clear the path. 2 long, 1 short meant the railway was approaching. Track crews needed to stand clear. Loaders needed to be ready. A series of rapid short blasts, 5 or more, meant emergency. Someone was hurt. All crews stop and medical team respond. The brilliance was in the acoustic design. Different whistle pitches for different locations. The main donkey whistle was deep, bass heavy. The railway whistles were higher pitched. The dam control whistle had a distinctive warbling quality. This meant you could tell not just what the message was, but where it came from. A felling crew 3 miles away could hear the main donkey whistle, process the code, and know exactly what was happening back at the landing. Old-timers claimed they could identify which specific whistle was blowing just by the sound. Lars Svensson, a hook tender who worked Washington camps from 1898 to 1934, told an interviewer in 1956 that he knew every whistle in Camp 12 by ear, could tell you which donkey was talking even in dense fog. But whistles had limitations. They could signal start, stop, warning, emergency. They couldn't communicate specifics. They couldn't say which tree to cut next. They couldn't report that a cable had worn through and needed replacing. For that, you needed the second layer. If this is blowing your mind so far, make sure you're subscribed for more true history like this. Every major logging operation employed runners, young men, usually in their late teens or early 20s, whose entire job was to move messages between crews. These weren't casual walkers. These were athletes. They covered 10, 15, sometimes 20 miles a day through terrain that would destroy your knees, across ravines, up ridges, through brush so thick you couldn't see your own feet. The runner system worked on fixed routes and schedules. This was crucial. It wasn't random. It was engineered. A large camp would have 4 to 8 runners working in rotation. Each runner had a specific circuit. The morning runner covered the felling sites. The midday runner hit the skidding crews and railway spurs. The afternoon runner checked in with the loading operations and maintenance crews. They carried a leather satchel with written messages from the camp boss, the head push, or the railway supervisor. But more importantly, they carried verbal messages, specific instructions, updates, problems. A runner might leave the main camp at 6:15 a.m., reach the first felling crew by 6:45 a.m., deliver instructions on which section to work that day, then continue to the second crew. By 8 a.m., he'd reached the skidding operation, picked up a message about a broken cable, and started back to camp. The head push, the overall, operations boss, would be waiting. He'd send the runner to the blacksmith with orders to fabricate a replacement cable. The runner would confirm the smith had the right steel stock, then head back out to the skidding crew with an estimated repair time. That's 3 messages delivered, 2 confirmations received, and a repair coordinated in under 3 hours across 6 miles of terrain. But here's what made it work. The schedules were fixed and known to everyone. If you were a felling boss and needed to send a message, you knew the morning runner would reach you between 6:45 and 7 a.m. You had your message ready. You didn't wait around hoping someone might show up. If the camp boss needed a status update from the loading crew, he knew the afternoon runner would return with it by 3:30 p.m. He planned accordingly, scheduled decisions around when information would arrive. The runners became so integral that camps built rest stations at the halfway points of major routes. Small shacks with a stove, water, sometimes food. A runner could warm up, check a written log to see if other runners had left messages, and continue. Some camps even used a relay system for urgent messages. Runner A would carry a critical message to the midpoint station, hand it off to Runner B, who was already heading out on his circuit. Cut the delivery time in half. There are documented cases of logging camps sending emergency messages 8 miles in under 90 minutes using runner relays. That's faster than you could drive it on modern logging roads. But even this system had gaps. Whistles told you when, runners told you what, but neither system helped with the most critical question: where? Where should we position the next set of trees for the skidding crew? Where exactly is that broken cable? Where did the loader crew move the log decks? For that, they needed the third layer. Walk through an old-growth forest in the Pacific Northwest today, and you can still find them. Rusted survey, stakes, faded paint marks on old stumps, the remnants of a visual communication system that spanned entire mountains. Every morning, before the felling crews started work, the timber cruiser and his assistant would mark that day's cutting zone. They used colored stakes. Red stakes meant boundary lines. Don't cut beyond this point. White stakes marked skid roads, the paths where logs would be dragged. Blue stakes indicated danger zones, areas where other crews were working or where terrain was unstable. But the real sophistication was in the flag system. Small cloth flags on tall poles marked active work areas. Different flag positions meant different things. A flag at the top of the pole meant work in progress, crew present. Halfway down meant crew on break but returning. At the bottom meant work completed, area clear. The skidding crews could see these flags from a quarter-mile away through the forest. They knew exactly where the felling crew was, where they'd been, where they're heading next. But there's more. The timber cruiser didn't just mark randomly. He worked from maps that showed the entire operation, every stumpage tracked, every railway spur, every landing zone where logs would be loaded. These maps were updated daily. The camp clerk would record which sections had been cut, which skid roads were complete, which landing zones were full. The timber cruiser would use that information to mark tomorrow's work zone. This created a feedback loop. The map informed the stakes. The stakes directed the crews. The crews reported back to update the map. Some operations took it even further. The Bloedel Donovan Lumber Company in Washington ran a system starting in 1914, where they used numbered stakes that corresponded to their mapping grid. Stake 4 B17 meant you were in Section 4, Row B, Stake 17. Any crew member could tell you exactly where they were using the stake system. If a cable broke and you needed the repair crew, you sent a runner with a message. Cable, down at 4, B17. The repair crew could grab their map, find 4 B17, and head straight there. No wandering, no searching. This same system helped prevent the deadliest logging accident. 2 crews working the same area without knowing it. Picture it. A felling crew is dropping trees on a ridge. They've created a widowmaker, a partially cut tree that could fall at any moment. They've marked it with a red flag, standard procedure, and moved to the next tree. 3 hours later, a different crew comes up from the valley to start skidding logs from that same ridge. The first thing they do is check for stakes and flags. They see the red flag on the widowmaker. They know not to go near it. They work around it until the felling crew can return and bring it down safely. Without that flag system, the skidding crew walks right into the kill zone. Someone dies. The old-timers had a saying, "Flags don't lie, but assumptions kill." It wasn't poetic. It was statistical fact. Camps that ran strict stake and flag systems had accident rates 60 to 70% lower than camps that didn't. But all of this, the whistles, the runners, the stakes and flags, only worked if there was someone coordinating it all. Someone who understood the entire system and could make it operate like a machine. That's where the fourth element came in. The genius of logging camp coordination wasn't just the communication tools. It was who could use them and how authority flowed. At the top sat the camp boss, also called the superintendent. He rarely left the main office. His job wasn't to manage every detail. It was to set the overall strategy and maintain the schedule. He decided which tracks to cut when, where to extend the railway, when to bring in more men. Big picture stuff. Below him was the head push, the operations manager. This was the man who actually ran the daily show. He coordinated between all the different crew bosses, allocated resources, and made real-time decisions. Then came the specialists. The hook tender ran the cable systems and loading operations. The loading boss managed the railway spurs. The falling boss oversaw the felling crews. The skidding boss handled log movement from stump to landing. Each of these bosses had their own territory, their own crews, their own section of the operation. But here's the critical part. They couldn't make decisions that affected other sections without going through the head push. This prevented the chaos that killed operations. If the falling boss decided to work a different section because the timber looked better, and he didn't coordinate with the skidding boss, you'd have skidding crews showing up to an empty work site while fresh-cut timber sat untouched somewhere else. The head push enforced the coordination. Every morning at 5:30 a.m. before breakfast, all the bosses met in the camp office. 15-minute meeting. Each boss reported the previous day's work and received his orders for the coming day. Those meetings were legendary for their efficiency. No small talk, no discussion. Boss reports, head push decides, everyone leaves. Old company records show these meetings averaged 12 to 14 minutes. But the real coordination happened through the runner and whistle systems we've already covered. The hierarchy determined who could send messages, who had authority to change plans, who needed approval. A felling boss could send a runner to the head push, saying, "We need 2 more Sawyers on this tract to hit quota." The head push could approve or deny, but that same felling boss couldn't send a runner directly to another crew boss, saying, "Send me 2 of your men." That would break the chain of command and create chaos. This seems obvious now, but you have to remember these camps operated in an era where many industries still ran on chaos and shouting. Factory floors were mayhem, construction sites were confusion, but logging camps couldn't afford chaos. The work was too dangerous, the operations too spread out, the costs of failure too high. So they built systems that rivaled military organization. Some camps literally used retired army officers as head push because they understood chain of command. The Snoqualmie Falls Lumber Company in Washington had a head push named Martin Graves, who'd been a supply logistics officer in the Spanish-American War. He ran Camp 14 from 1901 to 1918. Company records show his accident rate was 1/3 the industry average, and his production numbers were 20% above. He didn't achieve that through luck. He achieved it through system. Morning meetings, fixed runner circuits, strict flag protocols, chain of command. Everyone knew their role, knew how to communicate, knew who made which decisions. The military studied his operation. There are documents in the National Archives showing Army logistics officers visited Camp 14 in 1916 to learn his methods for coordinating dispersed units without radio communication. Think about that. The United States military, preparing to fight World War I, studied logging camps to learn coordination techniques. That's how effective these systems were. But no system is perfect, and when logging coordination failed, people died. The worst logging disaster in Washington state history happened on March 12, 1909, at the Dempsey Lumber Company's Camp 3. 17 men killed in 6 minutes. The failure wasn't mechanical, it was communication. The felling crew had been working a steep ridge for 3 days. They'd created what loggers called a hang-up, a partially cut tree that was leaning against other trees, held up by branches. Standard procedure was to mark it with flags and bring it down carefully with cables once the surrounding timber was clear. But the falling boss, a man named Peterson, didn't update the stake map that day. He assumed everyone knew about the hang-up because it was visible from the main skid road. The next morning, a skidding crew came up from a different angle, from below the ridge instead of the usual approach. They couldn't see the hang-up, There were no flags from their direction. The stake map hadn't been updated to show the danger. They started moving logs. The vibration from the donkey engine shook the hang-up loose. 40 tons of tree came down the mountainside, taking 6 other trees with it. The entire skid road became an avalanche of timber. 17 men caught in the slide, all dead before crews could reach them. The state investigation report is brutal in its conclusion. I'm reading directly from it. This disaster resulted not from mechanical failure, nor from the inherent dangers of the logging trade, but from failure to follow established communication protocols. Had the stake map been updated, or had flags been positioned on all approach angles, the skidding crew would have known to avoid the area. That report changed the industry. Within 2 years, Washington State passed regulations requiring logging operations above a certain size to maintain daily updated stake maps and to position warning flags visible from all possible approach angles. But mechanical communication failures happened too. Winter fog in the Pacific Northwest could get so thick you couldn't see 50 feet. Whistles became muffled and directionally confusing. Runners couldn't find trail markers. Flags disappeared in the mist. Smart operations had fog protocols. When visibility dropped below a certain threshold, usually judged by whether you could see the flagpole from the bunkhouse, all work stopped except essential maintenance. But some operations pushed through anyway. Production quotas, delivery deadlines, profit margins. The result was predictable. A study by the Forest Service in 1923 found that 28% of major logging accidents in Washington and Oregon between 1915 and 1922 occurred during low visibility conditions. The report noted, operations that suspended work during fog had accident rates comparable to clear day operations. Operations that continued work during fog had accident rates 4.3 times higher. Sometimes the communication system itself became the problem. Whistle codes worked great when everyone knew them. But new men, immigrants who didn't speak English, seasonal workers who'd never logged before, they struggled. A man named Johan Pedersen, who immigrated from Norway to Washington in 1912, told an interviewer decades later about his third day on the job. The main donkey whistle gave 2 long blasts. He thought it meant clear the area, so he ran. It actually meant start work. The boss found him hiding behind a tree 200 yards from the work site. The better camps ran week-long training for new men. Whistle codes, flag meetings, runner schedules, who to report to, how to send messages, basic survival stuff. But smaller operations, the independent loggers, the contract cutters, they'd throw men into the woods with an axe and hope they figured it out. Those operations had accident rates 3 or 4 times higher than the big established companies. The lesson was clear. Communication systems only work if everyone understands them. You can have the best whistle codes in the world, but if half your crew doesn't know what they mean, you might as well not have them. This became especially obvious when logging operations started hiring more diverse workforces during World War I. The big timber companies were losing men to the war. They hired Mexican workers, Chinese workers, African American workers who'd been shut out of the industry before. The camps that took time to train these men properly, that translated whistle codes into multiple languages, that used visual communication systems that transcended language. Those camps maintained production and safety. The camps that didn't adapt, that insisted everyone should just figure it out, those camps failed, either through accidents that shut them down, or through such low productivity that they couldn't compete. Communication wasn't a nice to have. It was the difference between a functioning operation and a death trap. In 1932, the first commercial radio system specifically designed for logging operations became available. Bulkova Radio Company of Seattle marketed them as the modern logger's telegraph. The ads promised instant communication across any distance. No more runners, no more whistles, no more stakes. Just push a button and talk. You'd think every logging operation in the Northwest would have jumped at the technology. They didn't. The first year, only 7 camps in Washington and Oregon bought radio systems. Industry publications from that era are full of old-time bosses explaining why they didn't need radios. One camp superintendent, whose name wasn't recorded, but whose letter was printed in the Pacific Logging Congress newsletter in 1933, wrote, "I've run this operation for 22 years without electronic contraptions. My runners know every inch of these mountains. My whistle codes have never failed. Why would I spend money on a machine that needs electricity and batteries when what I have works just fine?" Part of it was cost. A complete radio system for a large operation ran about $1,200 in 1932 money. That's roughly $28,000 in today's dollars. Not trivial, but the deeper resistance was cultural. These men had spent decades perfecting non-electronic coordination. They'd built systems that worked, systems they understood, systems they could fix with basic tools if something went wrong. Radios were foreign. If your radio broke, you needed a specialist from Seattle to fix it. If your runner got sick, you promoted another young guy who knew the trails. More importantly, the radio sellers didn't understand logging. They marketed radios as a replacement for the existing system. Buy our radios and throw out all that old-fashioned stuff. The smart camps realized you couldn't throw it out. You could supplement it. The first operation to successfully integrate radios was the Poison Logging Company in Oregon. They bought radio systems in 1934, but they didn't eliminate runners or whistles. They used radios for specific functions where instant communication really mattered. Emergency situations. Radios were faster than runners for getting help to an injured man. Major decision changes. If the head push needed to redirect crews immediately, radio beat the runner circuit by an hour. Equipment breakdowns. A broken cable could be reported instantly. Repair crew could start moving immediately. But for routine coordination, they stuck with the runner system. Daily messages, status updates, work assignments. The runners still made their circuits because that system worked and cost nothing to maintain. The stake and flag system, untouched. Radios couldn't replace visual markers. You couldn't radio the exact location of a danger zone to a crew working in dense timber, but a red flag on a stake told them immediately. And whistles? Those actually became more important with radios. Because radios failed, batteries died, equipment broke. But a steam whistle worked as long as you had steam pressure. You could always fall back on the whistle codes. This hybrid approach became the industry standard through the 1930s and 1940s. Radios for certain specific uses, traditional systems for everything else. There's a fascinating technical reason why full radio adoption took so long in logging. The equipment worked fine in open terrain, but inside dense old-growth forest, surrounded by 200-foot trees, radio signals bounced and scattered. Reception was terrible. Early radio systems used AM frequencies that didn't penetrate the forest canopy well. It wasn't until FM systems became available in the late 1940s that radio communication started working reliably in the timber. Even then, the old systems persisted. A 1952 survey by the Pacific Logging Congress found that 73% of major logging operations in Washington and Oregon still used whistle codes for shift changes and emergency signals. Runner systems were finally phased out in the 1950s, not because of radios, but because logging operations themselves changed. Truck logging replaced railway logging. Crews became more mobile and less dispersed. Chainsaws replaced handsaws and crosscut teams. The whole structure of operations shifted, but stakes and flags, You can still see them in modern logging operations. The colors have changed, the materials are different, but the basic concept of using visual markers to communicate danger zones and work areas, that never went away. Because some problems can't be solved with technology. Sometimes the old ways work better. By 1960, the great logging camps were mostly gone. The old growth timber was cut. The remaining operations were smaller, mechanized, using trucks instead of railways and chainsaws instead of hand tools. With them went the coordination, systems, the runner networks, the elaborate whistle codes, the daily boss meetings at 5:30 a.m. In some ways, this was progress. Radio communication was faster. Trucks were more flexible than railways. Chainsaws could do the work of 10 men with crosscut saws. But something was lost, something that modern operations researchers are only now starting to understand. Those old logging camps coordinated hundreds of men across impossible terrain without electricity. They did it with systems so simple, a new worker could learn them in a week. Systems so robust, they worked in fog, snow, and darkness. Systems so well designed, they had better safety records than many modern operations. A study by the University of Washington in 2003 compared accident rates between modern logging operations using radios, computers, and GPS against the old-time camps from 1920 to 1950, using only whistles, runners, and flags. The surprising finding, adjusted for the type of work being done, the old camps had lower accident rates per man-hour than modern operations. The researchers' explanation was fascinating. The old systems forced explicit communication. You couldn't assume someone got your message. You had to confirm it through the runner or by physically seeing the flag change position. Modern operations rely on radio communication, where messages can be missed, forgotten, or misunderstood. People assume their radio message was received without confirmation. The old systems also forced distributed decision-making. Each boss knew his territory, knew his men, knew his equipment. The head push coordinated, but didn't micromanage. Decisions happened at the appropriate level. Modern operations, with instant communication, often see management trying to control every detail from a central office. This creates bottlenecks and removes decision authority from the people who actually understand the situation on the ground. There's a military saying, "No plan survives contact with the enemy." The logging equivalent is, "No plan survives contact with the mountain." The old camps understood this. They built flexible systems that allowed for adaptation while maintaining coordination. The whistle codes didn't tell you how to solve a problem, just that a problem existed. The bosses had authority to make field decisions. We've traded that flexibility for the illusion of control. We have managers sitting in comfortable offices making decisions about situations they can't see, based on information that might be minutes or hours old, while the people on the ground wait for permission to do what they already know needs to be done. The old systems also created what researchers now call redundant communication channels, whistles and runners and flags. If one system failed, two others still worked. Modern operations often rely entirely on radios or cell phones. When those systems fail, everything stops. There's no backup. Hurricane-force winds knocked out cell towers across western Washington in 2006. Modern logging operations shut down completely. They couldn't coordinate without their electronic systems. The old camps would have shifted to whistles and runners. Work would have continued. I'm not arguing we should go back to pre-radio logging. The technology we have now provides real advantages, but we should understand what we gave up. We gave up systems that were simple enough for anyone to learn, robust enough to work in any condition, distributed enough that no single failure could shut down everything. Those are qualities that matter in any organization. Factory, office, military unit, Emergency Response Team. The logging camps of the 1890s through 1930s built coordination systems that would be the envy of modern operations researchers. They did it without consultants, without computers, without engineering degrees. They did it because their lives depended on it. So what can a logging camp from 1915 teach us in 2025? More than you'd think. First, lesson. Communication systems need to be simple enough that everyone can use them under stress. The whistle codes worked because they were binary. Stop, start, danger, clear, no ambiguity, no room for interpretation. Modern organizations love complexity, elaborate software, 17 different communication channels, meetings about meetings. But when things go wrong, when decisions need to be made fast, complex systems fail. The logging camps knew this. One blast means stop, that's it. No conference call required. Second lesson, redundancy isn't waste. Multiple communication channels aren't inefficient, they're insurance. The camps had whistles and runners and flags because they knew any single system could fail. Modern organizations talk about single source of truth and eliminating redundancy as if they're good things. But when your single source of truth goes down, you're dead in the water. The old camps understood that resilience comes from overlap, not from efficiency. Third, lesson. The people doing the work should have decision authority. The falling boss didn't need permission from headquarters to adjust which trees to cut. The hook tender could modify cable positions based on ground conditions. They had expertise. They had experience. They had autonomy. The head push coordinated their work, but he didn't micromanage it. Modern management often does the opposite. Every decision flows up to someone who isn't there, can't see the situation, and doesn't have the expertise to judge it. Fourth lesson, schedule beats flexibility when coordination matters. The runner circuits ran on fixed schedules. This seems inflexible, but it created predictability. Everyone knew when to expect communication. Everyone knew when to have information ready. Nobody wasted time waiting around, wondering when someone might show up. Modern workplaces love flexibility and agility. But often, that just means nobody knows when anything is happening. Meetings get rescheduled. Messages get lost. Nothing has a rhythm. The logging camps proved that fixed schedules, far from being rigid, actually enable better coordination because everyone can plan around known communication windows. Fifth lesson, visual systems transcend language and training. The stake and flag system worked whether you spoke English, Swedish, or Greek. A red flag meant danger. A white stake meant skid road. Universal. Modern operations rely heavily on written communication. Emails, manuals, procedures, all of which require language proficiency and time to read. The old camps knew that in dangerous situations, you need instant communication that anyone can understand. Hence the visual systems. These aren't historical curiosities. These are principles that matter for any operation trying to coordinate people across distance, under pressure, with lives or money on the line. The logging camps figured this out through trial and error, through men dying when the systems failed, through operations, succeeding when the systems worked. We'd be wise to study what they built. The great logging camps are gone now. The men who ran them, who knew every whistle code and runner circuit, they're all dead. The last of the old-time loggers who worked before radios died in the 1990s. But the forests they cut are growing back, and the systems they built, the principles of coordination they discovered, those are timeless. Whether you're managing a construction site, coordinating emergency response, running a factory floor, or just trying to get a team to work together across distance, the lessons are the same. Keep communication simple. Build in redundancy. Give authority to the people doing the work. Make schedules predictable. Use visual systems that everyone can understand. These weren't invented by management consultants. They were forged in the Pacific Northwest forests by men who couldn't afford to fail. 500 men, 10 miles, no radios. It worked because they built systems worthy of the task. The question is, are we building systems worthy of our tasks?